Space probes designed to study the sun are the last places you'd expect to have a moisture problem. Yet a recent investigation has found aluminum filters on 2 different satellites are degrading as water corrodes their surfaces. The filters help detect extreme ultraviolet emissions, so any kind of clouding is bound to affect their effectiveness. Though the issue has been evident for a while, scientists now finally know what's causing it. NASA's Solar Dynamics Observatory, and NASA and the European Space Agency's Solar and Heliospheric Observatory both have the same issue. In the first 6 months, SOHO's solar EUV monitor degraded by about 35%. In the 5 years following, it degraded by a further 60%. Solar probes aren't exactly cheap, and neither is launching annual recalibration missions to send new sensors into space. Figuring out why the filters are clouding could see to future solar probe missions being made more robust. In 2021, a team of scientists led by physicist Charles Tarrio of the National Institute of Standards and Technology experimentally figured out what it wasn't that is. A buildup of carbon causing the fogging, long considered the culprit. Now they've figured out what it is, and it's surprising: oxidation of the aluminum, caused by the presence of water and induced by ultraviolet radiation. As the layers of oxidized metal build up, the filter becomes foggy, preventing it from emitting the light waves the sensor is designed to monitor. The surface of aluminum is usually naturally coated with a surface layer of oxide, which occurs when oxygen atoms bond to the atoms on the surface of the aluminum. UV light increases the oxidation rate, causing additional layers of oxide to form. There's usually not a lot of oxygen in space to bond to the aluminum, but the presence of water, which contains oxygen atoms, could be a game changer. To test the water hypothesis, the researchers used the NIST's synchrotron ultraviolet radiation facility to generate EUV radiation, blasting it at an aluminum filter in a vacuum chamber into which water vapor had been introduced. In their experiments, Tarrio and his team did indeed find a layer of oxide on their aluminum sample that was much thicker than suggested by accepted theory, although not quite as thick as those seen on solar probes. Modeling, however, showed that with sufficient exposure around 10 months they would have achieved an oxide layer comparable to aluminum filters on space probes.